All right, good morning. So we're going to talk about Euler's method today, okay? So we have, okay. So the idea behind Euler's method, okay, is we're looking for a first order differential equation, okay, so we're just dealing with slope. Now, this might be something that you cannot solve, like nobody can solve. That happens, okay? Or it might be a nonlinear differential equation. It might be very hard to solve analytically. But the idea is that we're just looking for a slope. So we're just looking for dy by dx, okay, is equal to some function of xy in it, okay? And we're given some kind of starting conditions. We have some kind of x0, y0, okay? So you're given this, okay? In the problem, they're also going to tell you, like, what's h, okay? So this is also going to be given. This is also delta x, okay, change in x. Okay, this is the step. So once we've decided what the step is, we're kind of set for it. Your book will always tell you what step value you're supposed to use. There are different considerations, like the smaller your step value, the more accurate your solution is going to be, but the more time it's going to take you to actually get this. Okay, sometimes more error builds up too. Okay, so there's a issue if you take your step value too small. There's an issue there. Okay, if it's too small, okay, you might have to, even with computers today, you might have to wait a while to get an answer. Okay, so you want, if step value too large, okay, you're going to overshoot, and you're also not going to be able to get a good answer. So the idea for Euler's method, the way I always think about this is, if you've ever take a dog for a walk without a leash, okay, and I was able to do that because I grew up in the suburbs, but that's my experience with it. And what happens if you take and I'll say a relatively well-behaved dog for a walk without a leash, not perfectly behaved, but not just, I'm going to run away and that's it. If you start off in a specific direction, okay, here's your initial condition, here's your x0, y0. Okay, you're starting the walk, you take the dog off the leash. The dog will look at which direction you're walking in, and it will bound off in that direction, okay? And you might walk in that direction. But by the time you got there, like, the dog has already gotten bored, and they've decided, well, what direction are you facing? And it will bound off in that direction, okay? And you might end up going over here, okay? It's close, but at that point, the dog is going to look back and say, oh, which direction are you facing? You might be facing over there. So this is like your h value, okay? And then the direction it goes into, that's your slope, that's your dy by dx, okay? And then the dog looks back and says, oh, I need to reevaluate. The human is going over there, so we're going to go ahead and head off in that direction. So you might head off in that direction, okay? So it's going to go through and say, well, what's my different slope? What direction is the human facing? And go in that direction, and then it will periodically check back to see, like, well, what direction is it going? And then it'll bound off in that direction, okay? So that's what Euler's method is doing, okay? So just think about taking a dog for a walk. That's effectively your Euler's method. So numerically, okay, because that's not going to help you solve any problems, okay, you're going to be ending up with a dy dx, okay? We're approximating what's going on here. Okay, so this is dy by dx, but for finite stuff, okay? So approximate that. So this is equal to, right, our fxy. So first off, dy by dx equals f of xy. This has to be you have to put it in this format first, okay? Now what we're going to do is we're going to go ahead and we're going to start replacing some things. So we're going to have our dy. Okay, this doesn't have a letter, divided by dx, which we're going to call h, equals f of xy. So the idea here is we have a start, so we're delta y is equal to f of xy times delta x. Okay, we just swing this over. The numerical method we're going to use, okay, is we're going to make a table. Okay, this is your initial point. So you're going to have your x sub 0, y sub 0, y sub 0, x sub 0. Actually, I'm going to change it. So we'll do y sub 0, x sub 0. You'll see why in a second. So we have y sub 0, x sub 0. Okay. Now, I'll fill in the table first. So this is yx. Okay. The h, that's our delta x, remember? That's our step value. Once you've set this, you're kind of done. You have to set it, and it's always going to be. So this is going to be the initial point plus a step. Okay. This will be the initial point plus 2 steps. Okay, and so forth. So if they say h is 1/2, 0, 1/2, 1, 1.5, 2, etc. Okay, so whatever you put there, this h is a constant. Okay, so h is constant. And they tell you that in the problem. Okay, the next column is going to be f of x0, y0. Okay, whatever these 2 points are going to be. Okay, and the next point is going to be x0 plus h. Okay, etc. Okay, so this is just y1, y2. These are going to be x1, x2, x3, x4, etc. But we're getting them just by adding h's. This one, we're just going to take these 2 points and calculate. Okay. Then we have our h. So we have times h. Okay. And our new column, I always make a column for this, h times f of x I, yi. This is just the current point that I'm working on. Okay. And notice, right back up here, f of xy times the h times the delta x. This gives me my new y. Okay, so this is y I plus 1. So whatever we get here, okay, we turn the crank, and that is my new entry point. This is my new y. Okay, so this is y I plus 1, but from the previous line. So if it's 0, we now get 1. Okay, so h is constant, so we advanced the x's just by adding those h's. So it's a very slow march. This is whatever result happens to be. Okay, so we're going to get a new f of xy. So we're going to have this was f of x0, y0. This is going to be f of x1, y1. It's the new x1, y1. And we go through that whole process again, right? Figure out what this is, times it by h, and we're going to get a y2. And that's going to be our starting point for this guy. Okay, so a new point is going to be, we've advanced x twice, we've advanced y twice, okay, from here, and we're just going to keep repeating the process until we get to the end point. Okay, and it tells you like, well, the end point is going to be at 1. Okay, now the book will give you like definitely Excel level stuff to work with. Okay, and I'll show you how to do this in Excel. But on an exam, because these could be extremely tedious, I tend to work with h is 1/2. So we go from like 0 to 2. So you have 4 of these to deal with. Okay, but that's about it. Okay, if you do 4, you could do 400. Okay, so I'll just have you do a few of these. Or if I do a quiz with this thing, problem with the quiz, and I will give you the formula. Okay, you will get. Okay, here it is. You have y tick, right? Or dy by dx is going to be equal to f of xy times h. Okay, I'm going to look at what it is in the book, and I'm going to use exactly that formula so you are not surprised. You've got the same formula you've had the entire time you've been working with this. Okay, so I'm not going to change anything. We're not going to, I'll look in the book and I'll find the formula, and that's the one we're going to use. Okay, so that's the one you're going to have access to. You do not memorize this formula. You look it up when you need to. Okay, that is pretty much true for all numerical methods. Okay, just to give you an idea of what's going to happen next, or for numerical methods, it's kind of neat. You get an initial point, you get a slope, and you get your new point. Okay, so this is old, and this is new. Instead of just going off all the way, taking one step, other numerical methods, we're not going to do these, but pretty much back at half a step, they use this step to get half of one. And then that's going to be a little different because it's refined, and they'll use the refinement and then take another step and then halfway back and then change that one. So I'll like average the two slopes here. Okay. And you're eventually going to hear about Wangekutta. I found out that I pronounced this weird because this is what my teachers pronounced it was Wangekutta. If you look up, this guy, these two people, for differential equation solutions, you're gonna hear Runge-Kutta, which sounds awful to me. So I always pronounce it Runge-Kutta, but lots of people pronounce this different ways. These two guys aren't alive anymore to tell us what their proper pronunciation is. So I'm just going to pronounce it that way because that's how I learned it. But I'm not, if you hear it a different way and that's the first time you heard it and it's Runge for you, that nobody's, you're fine. I'll give you a funny look, but nobody's going to care. Okay, so let's go through a few examples to show you how this is done. We'll try to maybe do a couple, like at least one step by hand before we just punch it into the computer and let that handle it. Okay. All right. So let's go ahead and take a look at the homework. See, this is a good kind of a problem where, okay, we are going to say x squared plus y squared, that's my dy by dx equals some function of x and y. We are given the initial condition. They tell us use h is equal to 1/10. That's pretty common actually for this book. And approximate 0.5. Okay, so let's go ahead and start a problem. Okay, so what we're going to do is we're just going to double check, right? We have dy by dx equals f of xy. Okay, and notice this is a nonlinear differential equation. Okay, we can't separate it. Okay, we're kind of stuck. So the methods we learned in 10.2 ain't going to work, and the methods we learned in 10.1 ain't going to work. Okay, so we're just kind of stuck. This is a crummy first problem because you want to double check it somehow. Okay, actually, let me go ahead and do one thing to see if we can find a better problem to start with. I like this one a little bit more because this is a separable problem. Okay, or you can do this with the methods we learned in 10.2. Okay, so we could either solve this with dy by dx minus y is equal to 9, right? That's a first order linear equation. Or we could do a dy by dx times 1 over y plus 9 is equal to 1. Okay, so either way we want to do that, right? That'll work as a separable. That'll also work as a first order linear. I probably want to solve it this way. Okay, so let's do this one as a first approximation here. Okay, so we are given dy by dx equals something. Okay, we have a y sub 0 is equal to 4. Okay, h, say 0.1, that's going to be pretty constant. And we want to approximate y of 0.6. So when x gets to 0.6, we're done. Okay, so it starts off at 0, so 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. It's a long problem. Okay, but fairly easy. There's no x's in here. We don't care. All right. So let's go ahead and we'll have our x. No, we'll have our y, our x. The reason I put the y first is because the last term should go to the first column. Okay, this makes it a little bit easier to deal with. Okay, and then we could put an h in here. It's fine. Okay, that way we could remind ourselves what h is. Okay, and then we're going to have our x of x, f of x, y is equal to 9 plus y. Okay, and I always put an h times f of x, y here. Okay, h times whatever this was. Okay, and then we have our y new. Okay, so what's our start? Right, our start is 0. And y is, oh no, sorry, when x is 0, y is 4. Okay, so we got 4, we have 0. Our h is 0.1. This will be there forever. Okay, so Go ahead and do this. Okay, this will be, h is always going to be 0.1. So what's our next x? 0 plus 1/10. This will be 0.1. The next one will be 0.2. Okay, we're just adding the h to the x. All the other stuff that we're doing with this, x doesn't care. Okay, x just doesn't care. So what is our y plus 9, right? That's what we have for our value, right? Y plus 9. So we have 9. 4 plus 9 is 13. Okay. Then we're going to multiply it, right? We can be bigger here. So I'm going to be a little bit bigger. Okay, this is 13. Now, 0.1 times, right? 0.1 times 13. That's going to be 1.3. Okay. So what we're going to do is we're going to have our y new. So it's this y old plus y new. What was the first one? It was 4 plus 1.3. That's our new point. So our new point is going to be 5.3. Right? Now, this is going to come back down here. So this is going to be our new y, 5.3. X is now 0.1. Okay. And then we'll plug in. Okay. So f of x, y. So we have 5.3 plus 9. Okay. So this is 5.3 plus 9. So what is that going to be? It's going to be 14.3. Okay. 14.3 times 0.1 is 1.43. Okay. So this is going to go. And then our new y, 5.3 plus 1.43. Okay. And this is going to be 5.73. Okay. So let's go ahead and see what happens here. So this is our new y. So this is 5.73. Our new x is 0.2. We got that because we just said 0, 0.1, 0.2. What's our next x going to be? 0.3. Next y, we have to wait and find out. I don't know yet. Okay, this was still 0.1, 0.1. You don't really need this column, I suppose. Okay, if you know it's 0.3 or 0.1, you can just write that at the top and then just keep going. Okay, so 5.43 or 5.73 rather, plus 9. Okay, that's going to be 14.73. Okay, times 0.1. Okay, so that's going to be 1.473. Okay, and then we're going to add this. Okay, so this is going to be 5.73 plus 1.473. So if we do that, okay, so this is going to be 5.15. Really, we're not going to do anything, are we? Huh. Clearing you. All right. There we go. 5.73 plus. Okay, that reminds me, I get a calculus. My battery's my online class calculator. Okay, 5.73 plus 9. Oops, what are we doing? Oh, 5.73 plus 9 equals times 0.1 equals plus, there's my answer. Okay, plus the 5.73, because we're just going to add this. Okay, so we end up with 7.203. So this is 7.203. We got that by adding our change in y to a previous y. Okay. And then this guy here, this comes in 7.203. Okay, and then we're just going to repeat this process again. Okay, so this would be like the last, the last one I would really feel comfortable making you guys do. So maybe 1 or 2 more, okay, to do by hand, but that's about it. All right, so this would be right. This would be 7.73 plus 9. okay, times 0.1. So this guy here, this would be 1.6 rather, 1.6203. Okay, this would just be 7.203 plus 9. That's the function that we were given. Okay, right, it's y plus 9. Okay, and this is the function, the new function value times h. Okay, now what we would do is we would add this one to the previous one. So my y new equals in the previous two things. So we're going to have this guy plus 7.203. Okay, enter 8.823. Okay, and we're just going to keep going until we get to the approximate value. Okay, so for us, right, 0.1, 0.1, this is going to be 0.4. This would really be the last one I would want you guys to do. Okay, and actually, this y new value, this y new pair, this would be 8.823. So this would be the value x 0.4, y 8.823. Okay, and that's really all I want you to do by hand. That's enough. Okay, I would not want you guys to do this by hand for extended periods of time, because again, how easy is it going to be to make an arithmetic mistake here? Okay, so well, let's have a look-see and say, well, we live in the 21st century now, so why don't we do that? Okay, so we're going to have our y, okay, initial. We're going to have our x, okay. I'm going to put in my h, okay. Now we're going to have our f of x comma y, okay. The face-to-face class laughed at me because I always make my spreadsheets like I try to be really explicit with what's going on, because if you don't do it, nobody else is going to be able to follow it. Okay, so this is going to be y old plus y new. Okay, or plus current plus h times f of xy. Okay, just writing down like the arithmetic I'm going to make. Okay, and this will be y new. Y new. Okay, so I can keep track of it, because you really don't want to have a spreadsheet where it's like, what was I doing again? Okay, you don't want that. Okay, so for this method. Okay, don't really have to give them credit. He's got enough credit. Okay, but there we go. All right, so you might want to write down some stuff on here, like what the function is, but our starting points here, right? We had 0 and 4. Okay, what's my h? H was 0. No, my h was 0.1, Excel doesn't care. And this is just going to be the same thing regardless. I just did Control C, okay, to copy, Control C, and then Shift, and I just pressed down arrow a couple of times to highlight that, and then Control V, and just put them right here. There's dozens of ways to do this. Not, also including just typing them in. So just Control C, made myself a few things. Okay, so this x, right? New x is going to be plus the one above it, plus, and what I did, you could do it this way. If you wanted to just put it at the top, if I press F4, that puts little dollar signs around it, and it keeps it constant. Okay, I don't need to do that because I'm making a little column, and I can just always add plus the one above it, okay, plus this guy right here. You can do this a number of different ways, okay, but I think I can Control C this thing, go down a few points, and then, yeah, it looks like we're doing everything we wanted to do. We'll do one more, even though we're not going to need this one. Oops, oh, Control C, Control V. All right, so what we're going to do is we're going to say y plus 7. So we want plus whatever the y value was plus 7. Okay. Now we can't control C, control V because this guy doesn't have a whole thing yet. Okay. So if we do that, again, I just control C, control V. It's just going to do it the best it can. Okay, because I don't have a value here, it's just going to submit X, so it's 0. So 0 plus 7. Do that. If you press F2, it highlights what the colors are. Okay, so that was F2, that was the function key 2, and it tells you like what the value, the formula value is going to be for that one. Okay, so that's useful for checking. Okay, so this one's going to be plus. I said point. We could just say 0.1. It'll take that. Okay, times the previous one. Okay, so that's going to be this one. And I'm going to go ahead and check this one. So Control C, Control V, all going to be 0.7, right? So as we have. Right? I'm just putting the Control C's, Control V's because eventually this is going to be like my new point. Okay, so the new point, right, is the old point, right, plus the step. Okay, this is where the dog ran off to. Okay, 5.1. Right, that makes sense, right? 4 plus 1.1, 5.1. So I'm going to Control C this one. Control V. Okay, and again, it didn't, it updated because it's all 0.7s times the 0.1. Okay, and then this one here, this is going to be plus. So I just copied, and I'm just going to take my newest point, put that in, plus there. Okay, and see how everything updated? So we did. So if I do that, right, Control Z, that's undo. It's the most important number. Okay, and Control Y is yank. It brings it back. Okay, so Control Z undoes. Control Y, that is to yank it back into existence. Okay, so if you accidentally undid too much, you can Control Y and say redo it. Okay, so that's what that means is redo. Okay, so we just went through here. Right? So if I Control C, okay, Control V, let's take a look at what happened. So my F2 button, again, highlights what happened. So this is just the previous one here. Okay, and that's what I want. There's my new Y value, your best friend here. That's my Y value. And it's just going to turn the crank. And notice the X doesn't really matter in this problem. Okay, but that's what we're going to end up with. Okay, F2 here, checking. So it's the previous number, previous Y, times, or plus rather, the step value for Y, and then we're going to have our value. That's our slope. Okay, so we can say Control C. We can actually do this now, and it'll go ahead and update for everything. Okay, but that's how you go ahead and do this in Excel. Okay, and what you can do now is we have a bunch of XY pairs, don't we? We have a bunch of XY pairs. So effectively, we can approximate our function because we're going to have a graph. Okay, so I'm going to just highlight my X and Y here. Okay, we're going to go to Insert. Okay, and I'd like to go to a graph. Okay, and I almost always use the scatter plot. So that's this one down here, scatter. And now you can use one that does this, okay, etc. Okay, so I'm going to go ahead and use one that has the dots and the lines because I want to see like what my actual values are going to be. Okay, and we're going to have to change this a little bit because this is not the graph I wanted. The Y's are on the X-axis, etc. So what we're going to do is we're just going to switch row and column. I think this will do it for me. Nope, care about that. Select our data. Okay, let's go ahead and move. Okay, so we're going to add what is my X values. We're just going to copy it. So in this case, it would have been better to write it properly as XY and inserted by 1. My Y series, so we'll do our Ys. Okay, just to make it better. Euler's method. Euler's method. Chapter 1, or problem 2. And that's my series name. And we'll say OK. Euler's method, problem 3, problem 2. And that's what our function is going to look like. Okay. Now, what we're going to do, because it wouldn't be complete, a lab wouldn't be complete without the actual answer, right? So this effectively what we did was had a lab, right? So what we're going to do is we're going to say, aha, well, we have y by dx, right? Or y prime is equal to y plus 7. And we are given that y equals 4 when x equals 0. So we'll go ahead and say y prime minus y is equal to 7. Let's get our integration factor. So that's e to the negative 1 integral dx. Okay. So that's just going to be e to the negative x. All right, don't forget the negative. So we're just going to roll that in. Okay, so that's going to be y prime e to the negative x minus e to the negative x times y is equal to 7e to the negative x. Okay, don't know why that happens. Check this one out. This is going to be the derivative of e to the negative x times y. Okay, so we do the derivative of the first, that's negative e to the negative x times y. So the derivative of the first times the second plus the first, y times the derivative times the second. Okay, backwards. Derivative of the first times the second plus the first times the derivative of the second. That's what I wanted to do. So this is the first times the derivative of the second. That's exactly what we have up here. Right? We have a negative e to the negative x, y, plus y prime e to the negative x. It's written backwards because I wrote it backwards. And this is equal to, right, 7e to the negative x. So this is going to be e to the negative x, y is equal to, integrate this, negative 7e to the negative x plus c, right? So we're going to go ahead and multiply by e to the positive x. That'll be 0. So that's y is equal to negative 7 plus e to the x, c e to the negative x. Okay. Now, at x equals 0, y is equal to 4. That was our initial condition. So we're going to have 4 equals negative 7 plus c e to the 0 is just 1. So we'll go ahead and add 7. Add 7. So we have c is equal to 11. So our proper formula here is negative 7 plus 11 e to the x. So what I'm going to want to do here, okay, is we're going to go ahead and make a new column. So this is the true value, okay. And what I'm going to do is I'm going to say, well, here's my x's. What we're gonna go ahead and again, this is completely up to you. I'm just doing this because this is how this spreadsheet makes sense to me. Okay. So we'll say y x true. All right. So what we're going to do is we're just going to say plus. Here are my x's. I'm just going to copy them. So my copies. So Control C, Control V, Control Z. Let's see. We want to insert. I want to paste. Paste values there. Okay, and my y trues. Okay, and then what we're going to do is we're going to say, well, this is minus 7 plus 11 times exponent and whatever this is. Okay, Control C. Just going to go to the bottom. Okay, and those are my true values. So what I want to do on my graph here is I'd say, well, what's this going to look like? Okay, so we've got inserts. I want to add to my graph here. So let's see what we want to do. Now that I want to do that, select data. There we go. So we're going to add, and again, this is the true value, true solution. Our x values are going to be the same. Okay. And our y values are going to be this one. All right. And you can see, and this is supposed to happen. Okay. You're going to be off because the dog can't track you exactly. Okay. You're going to be off, but it's not going to be by much. All right. If you end up with like a way different curve or a way different shape or a way different thing, double check you guys have your stuff set up correctly. Okay. So we're off by a little bit. The book is going to go ahead and do smaller and smaller and smaller H's. I'm not interested in doing that to you. So the book's interpretation of what's going on is going to be a little different. All right. So what I'm going to do is go ahead and change all the due dates on everything so that you guys have a chance to finish some stuff up. Okay. So I know we all got behind a little this week. I'm just going to extend some dates here and see how we're going to go. All right. So there could be a quiz one on a quiz like this. I will absolutely give you the formula. Okay. I'd only pretty much go down to about maybe to this one, right? You're given this one 1, 2, 3, and the fourth one you've got to calculate is going to be the end one. It'll probably be like by half. Okay, each will be a half. So don't expect to be too close. Okay, because these were all by tenths. But you know, I just want to say, like, can you go through and follow this idea? Okay, so that's what we're going to do. Okay, I'm going to go ahead and sign off, and then we'll talk more.